Bismillahirrahmanirrahim. This is Fayaz Manchandi, Professor of Chemistry. So, dear students, this is a class first year. So, in the previous lectures, we done up to the wave number. Now, in the first year chemistry, we start the topic defects of Bohr's atomic model. Defects in Bohr's atomic model. Dear students, Bohr atomic model depends upon the circular motion of the electrons in orbits, circular way, circular path. So according to this model, we have to see what are the defects in Bohr's atomic model. First of all, you done maybe in the lower classes spectrum. In lower classes, maybe you know that what is the spectrum. Students, there are two types of spectrum. Main. One is a visible spectrum and other is called an invisible spectrum. Visible spectrum means we can see by our naked eyes. This is called visible spectrum. Just like rainbow. This example I am giving you. And there is another one which is called invisible. We can't see this one. These are the two main spectrums, visible and invisible. Now we will see the visible spectrums. There are two visible spectrums. Number one spectrum is called continuous spectrum. Continuous, just like rainbow. Rainbow is a type of continuous spectrum because all the colors are merged with each other. There is no discontinuity between these colors. And there is another one which is called a discontinuous spectrum, or we call line spectrum. So in the atoms and molecules, line spectrum is going to be formed. So in the atoms and molecules, the line spectrum is formed. So when the boundary line between the colors cannot be marked, this is called a continuous. Cannot be marked, this is called continuous. Otherwise, spectrum is called a line spectrum or discontinuous spectrum. So the first defect in Bohr model is, according to your book, page number in my book 39, and if you see your book, there is a topic 2.24 first year class, grade 11. Bohr's theory cannot explain the origin of the spectrum of multi-electron system. This is very important. One is called a mono-electronic system. Mono-electronic system means hydrogen. Hydrogen has atomic number 1. So it has one electron. This is a mono-electronic system. There is another one. Helium positive 1 after atomic number 2. So when the helium loses one electron, atomic number 2, this only one remains. So this is also a mono-electronic system because one lost, etc. So Bohr model is only applicable for the mono-electronic system. This theory is not applicable for the polyelectronic system, just like helium atom, which has 2 electrons. Helium, boron, atomic number 5, 1s2, 2s2, 2p1, 3 electrons in the outermost shell. Beryllium, Be, atomic number 4. So these are a multi-electron system. they have more electron present in the valence shell. So according to this point, that Bohr theory is not applicable for the multi-electron or poly-electronic system like helium, lithium, beryllium, like this one. This is the one point. Second point is that when a spectrum of hydrogen gas is seen through a powerful spectrometer, spectrophotometer, its complete name, it is an instrument, so it can be used for the IR region, visible region, and also ultraviolet region. So a spectrum, photospectrum. So this is called a spectrometer. The original spectral lines are replaced by several very fine lines. So if you are going to see the hydrogen spectrum in the spectrophotometer, so these lines, the original lines, are divided into many other lines. So that is why this Bohr theory, K shell, L shell, M shell, N shell, they can be divided into other lines. So it means that there must be other lines also. So this is the second defect. Bohr suggested circular orbits. When you are going to distribute K shell, L shell, they are circular orbits. But according to other, they are going to be different shapes, just like P shape, D shape, F. They are not circular. Dumbbell, sausage, complicated. But it's proof that motion of electron is not in a single plane, in three-dimensional. The movement of electron is three-dimensional, not in a single plane, but three-dimensional space. When an excited atom of hydrogen giving atomic emission spectrum. Dear students, there are two kinds of line spectrum. One is absorption spectrum and other is called emission spectrum. When electron drops from higher energy to lower energy, the energy is going to imitate and the spectrum is formed is called atomic emission spectrum. When electron jumps from lower energy to higher energy, means ground state to excited state. So this is called absorption spectrum. So when it is going to be placed in a magnetic field, the spectral lines are further split closely spaced. So this type of splitting of the spectral line is called Zeeman effect. So when the hydrogen spectrum is placed in a magnetic field, then we call Zeeman effect. Must remember. Similarly, when the excited hydrogen atom is placed in a strong electrical field, before magnetic field, now electrical field. So similarly, more splitting of spectral lines take place with the we call Stark effect. So Bohr theory did not explain the Zeeman effect and Stark effect. So this is another defect of the Bohr's atomic model. Now, dear students, majority of the scientists, their thought is that electron is revolving in three-dimensional. Electron is revolving in three-dimensional. So when we are going to study further, so there are many scientists. So one of the important or very effective scientists is Heisenberg. Heisenberg. We call Heisenberg uncertainty principle. Heisenberg uncertainty principle. According to this, I told you that according to Bohr's atomic model, electrons are moving in orbit in specific velocities, specific radii, in circular path, circular motion, we call orbits, in one plane. This is according to Bohr's model. But according to the uncertainty principle, moving electron in orbit, if the electrons are moving in the orbit, according to uncertainty, velocity of electron and the position of electron cannot be measured exactly. Actual wording in your book is that both the exact position and velocity of the electron cannot be measured exactly if electrons are revolving in three-dimensional. This is called uncertainty principle. So students, in order to solve this difficulty, there is another very popular, or we can say other scientist, which is we call Schrödinger, German scientist, mathematician, physician. Schrödinger. So he solved difficulty to derive the wave equation in the physical chemistry or modern physics, because he was actually mathematician and physics. So that's why he derived mathematical derivation, mathematical equation we call it wave equation. So according to Schrödinger equation, wave equation for the hydrogen atom, again there is a defect. Hydrogen is a monoelectronic system. He is not talking about the multi-electron system. So I am not going to detail this. For the hydrogen atom, according to him, although the position of electron cannot be found exactly, the probability of finding electron can be ascertained. This is the point of Schrödinger wave equation. So, dear students, if you see the calculation of radius of Bohr model, if you go back, radius of Bohr atomic model was for first orbit, if you remember, that was 0.0529 nanometers. This is according to the Bohr's model, if you go back. But if you going to round off this will be a 0.053 nanometers. Say. So now, conclusion is that because these are theories, principles, theories, not law, they can be changed by the passage of time. When time is going to be passed, their theories, their principles are going to change. So in Bohr 1913, he presented his model, that's called Bohr's atomic model, and I read all defects according to latest research. But still, this is also mathematical theory, mathematical derivation. This is not a law. So still maybe the modifications come. So according to the Schrödinger wave equation, there is a probability of finding electrons. So he calculates the radius same as the Bohr model. Same. This is for the Bohr model and this is the latest. So if you are going to round off 2, 9, you get 3, same, 100% same. It means that you can't discard the Bohr model. Okay, there are some defects, but you can't completely discard because the calculation of radius by the Schrödinger and by the Bohr same, no difference. So that is why this model is also still exist. We can't discard completely. So according to the latest research, the electron can revolve dual character means dual nature. Dual nature means it has a wave as well as particle. This is latest research. Both wave nature as well as particle nature, because Bohr model suggests particle nature. So that's why the scientists, they didn't discard this theory. So this is the uncertainty principle. Dear students, here this topic is going to be over. This may be short question asked from here, maybe the MCQs asked. You have to complete it. Now I am going to start another topic which is called a hydrogen spectrum. Hydrogen spectrum. Hydrogen spectrum. Now, as you done the previous calculation, if you see my previous lecture, there was a formula for the wave number. See the previous lecture, there was a calculation for the wave number. This is the wave number. So wave number is equal to R Rydberg's constant, which is a constant value which is given in your book, 1 over n1 square minus 1 over n2 square. This is the formula of wave number, where n1 is the energy level 1 and n2 is the energy level 2. Orbit 1, 2, 3, 4 like this. So this is the calculation for the wave number as you done in the previous lectures. So dear students, with these equations, Bohr was able to predict the wavelength. Wavelength, because wavelength is inversely proportional to wave number. If you have a wave number, so wavelength lambda is 1 over wave number. So you can calculate the wavelength. So Bohr was able to predict the wavelength in a hydrogen emission spectrum and electron transition, change of energy levels from one orbit to other orbits according to the hydrogen spectrum. Now, there are some spectral series. Very important. Spectral series. The wave number of different spectral lines can be calculated corresponding to the value of n1 and n2. In the hydrogen spectrum, different spectral series I told you. Different spectral series of lines have been identified for N1 and N2. So, students, number 1, you should remember this. These are very, very important. Number 1 spectral series is called Lyman series. Lyman series. So this series is existing in ultraviolet region. It gives a invisible spectrum. Invisible, ultraviolet, cannot be seen. And there is one thing very important. Lyman series and 1 must be 1. Students, and 1 will be 1 if there is a n1 given. So this is called a Lyman series. Dear students, you must remember, don't mistake. If it starts from orbit number 1, n is equal to 1, so it is called Lyman series, means ultraviolet region. Then N2 will be maybe 2, maybe second orbit, maybe third if electrons drop from 2 to 1, 3 to 1, 4 to 1, 5 to 1, 6 and 7 and so on and so forth. If electron drop from 7 to 1, means n is equal to 7 and n1 is equal to 1. Maybe n is equal to 2 is equal to 3 and n1 is equal to 1. So when don't see, this is the first line. Don't say second line. 2 is for the orbit. First is given here. So this 2 is for the orbit. 2, 3, 4, 5, 6, 7 orbits. So if the examiner asks you calculate the wave number and wavelength of second line of the Lyman series, R is a constant, a Rydberg constant. You can see the previous topic. And when he said Lyman series, so n1 must be 1. Because he is saying Lyman series. n1 must be 1. And he said calculate the second line. So this is the second line. 3 is the second line. 1, 2, 3, 4, 5, 6. So it means n2 will be is equal to 3. So this is the second line of the Lyman series. Second line of the Lyman series. Third line of the Lyman series. Calculations are present in your book. If you see, if you open the next page, if you see the next page, first line, and 1 is equal to 1 for the Lyman series, and first line is 2. Second line for the Lyman series, n1 is equal to 1 and n2 is equal to 3. Third line of the Lyman series is n1 is equal to 1 and n2 is equal to 4. Limiting line means n2 is infinity. Limiting line means n2 will be the infinity. Put the value and calculate the wave number as well as wavelength. This is a formula I told you. So dear students, this is about the Lyman series. Now, second is the Balmer series. Number 2, we call Balmer series. Dear students, this is the only series which is present in the visible region of the spectrum. Means you can see all colors by naked eye.